Today's problem is top k frequent in array. Given a non-empty integer array, your task is to find and return the top k elements which have the highest frequency in the array. If two numbers have the same frequency, the larger number should be given the higher priority. Okay, so this is not a bad example. We have an array. K is 2. And the two numbers with the highest frequency are 4 and 1. They both appear twice. Because 4 is the larger number, it gets the priority in the output, and so the output is 4 and 1. Second example is similar. Let's see. Array size will be between 1 and 10 to the 5th, 100,000. Array elements will also be between 1 and 10 to the 5th. K is between 1 and the number of distinct elements. Time complexity, n log n. So we can do some sorting or ordering of the elements, auxiliary space, n, O of n. So yeah, we will be using an auxiliary data structure for this, a heap. Company tags, Amazon, Microsoft, arrays, hash, sorting. Yeah. I'll tell you, I tried sorting on this, and I mean, just a straight sort timed out. Well, we'll talk about that a little bit more. But okay, let's take a look at what we're doing here. I mean, it seems pretty clear that the first step is to iterate through the array. Well, here we're going to define a hash map. We're going to iterate through the array, and for each element of the array, we're going to increment its frequency in the map. Okay, so when we get done with that for loop, we've got a hash map containing all the elements of the array, all the distinct elements of the array, and the frequency with which they occur. All right, we're going to put those in a min heap. How are we going to do that? Well, actually, before I look at that, let me say that we are going to the way we're going to put elements in the heap is we are going to loop through the entry set of the map, which is the set of all the key value pairs. Okay. We are going to put those into two element integer arrays in reverse order. In the map, it's key value. In the heap, it's going to be value key. It's a little bit easier to sort it that way, I think, because really the primary sort is on the value. We want the highest frequency. So, new priority queue. We have to provide some sort of comparator here, because there is no default ordering of integer arrays. So for us, what we're going to do is we're going to say if the first, we're comparing two element integer arrays. If the first element is equal, meaning that the frequency is equal, then we're going to order it by the number in descending order. If the frequencies are not equal, we're going to order it by the frequency in descending order. Okay, so that's going to give us a min heap. Every time that we add a new entry to the min heap, we're going to check and see, is the size greater than k, and if it is, we're going to remove the element at the top of the heap, because that is going to be the min value, and we're looking for the max value. When we get to the end of this, we're going to have a heap of size k with the k highest frequency elements. Okay? Define an array list to hold the result, and while the heap is not empty, we have to reverse this again because it's a min heap, and we want the highest frequencies first. So every time we take something off the heap here, we're going to put it at index 0. So effectively that's going to reverse the min heap and put the most frequent elements first. All right, let's try this. Okay, good so far. Submit. All right, good. See all my attempts. Yeah, 1 out of 2. This is an n log n algorithm because operations on a priority queue, because the priority queue does the work of keeping the elements sorted. So adding to a priority queue is not O of 1, it's O of log n. Okay. So really the whole thing is n log n. Now I did try the first time creating the map, putting the map entries in a list, sorting the list, and it timed out. That's also n log n, but I guess the multiplier is greater. But this seems to be the way. To do it. So okay. Yeah, go ahead and like the video. You can subscribe to the channel. It's free, and we'll see you next time.